Algebra 3, Chapter 1, Section 4, Quadratic Equations and Applications. When we go to solve a quadratic equation, it is important that we make sure it is in general or standard form. General or standard form looks like this: ax squared plus bx plus c equals 0. The a, b, and c represent numbers in the equation. Notice it's in descending order with the highest powered variable first. To factor a quadratic equation means to separate it into factors, which are expressions that when multiplied together give you the original equation. And there are several ways to factor equations, and I'm going to demonstrate 3 of them for you. It's important that you are able to factor efficiently. It doesn't really matter which method you use, but you must be able to use one throughout this course. Factoring is going to come back again and again and again. The sooner you get it down, the easier it's going to be later on. Our first factoring method is the classic guess and check. So we're going to factor 2x squared minus x minus 6. The first thing we need to do is to check to see if there is a common factor for all 3 terms. The reason for this is that if there is, and we factor it out, it's first of all going to give us smaller numbers to work with, which always makes it easier. But sometimes it's actually impossible to continue factoring until you've done this. The second thing we need to do is consider all the possible factors of the leading coefficient, in other words, of 2. Now we're really lucky because we only have one possible combination here, and that is 2x times x. So we're starting with our 2 parentheses. 2x and x are going to be in the first position in each parentheses. If the leading coefficient has several factors, you need to make a list of the possible combinations so that you are considering every possibility. Now we need to consider all the possible factors of the last term, which is negative 6. And there are 4 possible ways to get negative 6 by multiplication. We have them listed there. Notice we need to consider that either the first or the second factor could be negative. Now, when we put those together with the 2x and the x, we end up with 8 different possible ways of combining these numbers that will give us a starting term of 2x squared and a final term of negative 6. But only one of these will give us the magical middle term that we're looking for. So what we need to do is we need to test our possible answers and see which one gives us the correct middle term, which is negative x. To do that, we will multiply the outer and the inner and add them together. So you're really doing FOIL, but we don't need to do the first because we already know the first works because we made it work. We know that last works because we picked 2 numbers that would make that work. So what we really need to check are the combination of the outer plus the inner. And as you go through this, you see that my third combination of 2x plus 3 times, or minus 3 times x, 2x plus 3 times x minus 2 gives us the middle term of negative x that we're looking for. So 2x squared minus x minus 6 factors into 2x plus 3 times x minus 2. Now a second method is the slide method. And so this is going to explain how to do that. We begin with ay squared plus by plus c. Now you may wonder, why are we using y? Because the resource I used to get this used y. Replace it with x if it makes you happier. The method stays the same. So I'm giving you the steps on the left here, an example on the right. The first thing we're going to do is we're going to multiply the a times c together and throw away the a for a moment. So we're going to put y squared, getting rid of the 6, minus y minus 12. We're putting the a times c, the 6 times negative 2, in place of the c. Now we've got something that's fairly easy to factor. It's always easier to factor something when you don't have a number in front of your square term. So we find 2 numbers that give us negative 12 when we multiply them together, but add up to negative 1, and that gives me y minus 4 times y plus 3. Now we have to bring a back into the picture. So that 6 that we got rid of up front is going to come back, and it's going to go underneath the 4 and underneath the 3. So now we have y minus 4 over 6 times y plus 3 over 6. Now we're going to reduce. 4 6 reduces to 2/3, and 3 6 reduces to 1/2. And if you still have a denominator remaining in either or both parentheses, then as a final step, you're going to slide that denominator out from the bottom of the fraction and in front of the variable. So the 3 comes in front of the y, the 2 comes in front of the y, and we have 3y minus 2 times 2y plus 1. If you check this by multiplying it out using FOIL, you'll see that you get what we started with. Okay, so here's another example just to make sure we have it. By the way, you should always pull out any common factors before you begin this method. Of course, you should do that with any of our factoring methods. First thing you're going to do is you're going to slide the leading coefficient to the end and multiply it by the constant. So we get x squared plus x minus 30. Then we're going to factor x squared plus x minus 30. Two numbers that give me negative 30 when I multiply them are 6 times negative 5. And when I add 6 plus negative 5, I get 1. So I'm getting the numbers I want. Now we bring the 3 that we threw out back in. We'll put it under the 6 and under the 5. The next thing we're going to do is simplify our fractions. So now we have x plus 2 times x minus 5/3. The x plus 2 will remain the same since it has no denominator. The 3 in the second parentheses will slide out from under the 5 and in front of the x. And we're left with x plus 2 times 3x minus 5. Our third method for factoring is called grouping. And again, you want to pull out any common terms first. Now, this is going to start similar to the slide method. We're going to find the product of the first times the last, which is 10. We're going to think of two factors of 10, so two numbers that multiply to give us that 10, that will add up to our middle term, to 11. Well, 1 times 10 is 11, so we're going to use 1 and 10. Now what we're going to do is we're going to write 11x as 1x plus 10x, so we're splitting it up. So you can see we've got 5x squared plus 1x plus 10x plus 2. Then we're going to group into two pairs of terms. We're going to split this right down the middle. We're going to group the 5x squared plus 1x together and the 10x plus 2 together. Then for each parenthesis, you're going to factor out a common factor. For the first parenthesis, that's going to be x, and for the second, that will be 2. Now notice when we do that, we have x times 5x plus 1 plus 2 times 5x plus 1. Those two parentheses are identical, which means they now become the common factor. So we put 5x plus 1 out front, and then in parentheses we put what remains, which is x plus 2. If you check this out by multiplication, you'll find that we ended up with exactly what we started with. Here's another example just to get some more practice. The first thing we do is we multiply the 4 times negative 15 and get negative 60. We need two things that multiply to give us negative 60 but add up to 7. And we find that that's going to be negative 5 and 12. So we're going to rewrite the problem, and instead of 7x, we're going to put in negative 5x plus 12x. We then split the problem in half. For each group, we factor out a common factor. And again, notice the two parentheses that are formed after we factor out the common factor for each are identical. If these are not identical, then you either cannot factor it or you've made a mistake somewhere. The 4x minus 5 is the same, so that comes out front, and what's remaining is the x plus 3. Okay, when we're solving for x, we can factor sometimes, but we do have other options, and it's important that we have other options because not every quadratic equation can be factored. So it's really important that you master either completing the square or the quadratic formula for those situations where factoring is just not possible. Now, when a quadratic equation is in the form ax squared plus c equals 0, we can really just isolate the x squared and take the square root of both sides. For instance, in this case, we would subtract the c and then divide by a. That would give us x squared equals negative c over a, and then we take the square root of both sides to get x by itself. Whenever you take the square root, in order to cancel a square, don't forget you must put a plus or minus on the answer. And this process is called extracting the square root, and that's the first one we're going to look at. We're also going to be looking at completing the square, which is a method of taking a standard quadratic equation and arranging for it to factor into a perfect square. And then we will also look at the quadratic formula. First of all, extracting the square root. This is a very simple one. We got z squared minus 7 equals 29. We're going to add the 7 to both sides. We have x squared equals 36. We're going to take the square root of both sides, putting the plus or minus in front, and we find that x is either 6 or negative 6. Notice that we can only use this method if we do not have a variable, a non-squared variable as part of the equation. Let's talk for a minute about completing the square. Now, this may not be your method of choice, but I do want to warn you that later on in the year when we get to conic sections, completing the square is going to come back to haunt us, so it's a really good idea to at least get a good hold on the process, even if you choose not to use it for what we're doing in this chapter. Now, we've already seen it's fairly easy to solve a quadratic equation by taking square roots. That's what we just did. But the equation has to be in what is called vertex form. If it looks like this, y equals a times x minus h squared plus k, you'll be able to solve it. You can subtract the k, divide by a, take the square root, and then add anything that's in there with the x. If we can get our quadratic equation to look like this form, then we'll be able to use this process for solving it. So completing the square takes ax squared plus bx plus c and converts it to this form. So how do we do it? Well, first of all, let's look at how to do it when the number out in front of the x squared is 1. The first thing we do is we subtract the c, the number without a variable, from both sides. Then what we're going to do is we're going to take the number in front of the x, the b, we're going to divide it by 2 and square it, and that will get added to both sides. So now we've got x squared plus bx plus b over 2 squared, but you have to do it to the other side also. And what that does on the left, this is now a perfect square trinomial. And it factors into x plus b over 2 squared. Now on the right side, that's all going to combine just to give us a number. We'll then take the square root of both sides, and then we'll subtract anything that's in there with the x, and that will give us the value of x. If the number in front is not equal to 1, you're going to do the exact same process with one slight change. Before doing anything else, you're going to divide everything by a. Or you can subtract the c from both sides first and then divide by a. But before you actually begin completing the square process, you want to divide everything by whatever that number in front of the x squared is. Then you're going to go through the exact same process that we just talked about. Now I know it looks really messy using letters instead of numbers, so we're going to do an example using numbers. Okay, so what we're going to do here is we're going to solve this by completing the square. So the first thing we do is we add the 14 to both sides of the equation. So now we've got 2n squared minus 4n equals 14. We're going to divide everything by 2 because we don't want a number in front of our squared variable. Now sometimes that doesn't make for really nice numbers like it does here. Sometimes you're going to end up with fractions. That's okay. Don't panic. The method still works. The next thing we're going to do is we're going to take the 2, the number in front of the n, we're going to divide it by 2, and we're going to square it. So negative 2 divided by 2 is negative 1, negative 1 squared is positive 1, and we're going to add that to both sides, because if you do something to one side of an equation, you must do it to the other. So now we've got n squared minus 2n plus 1 equals 7 plus 1, or 8. Now we're going to factor n squared minus 2n plus 1, and it just so happens that it's a perfect square. N minus 1 squared equals 8. Now we can take the square root of both sides, And we can simplify that square root. So we have n minus 1 equals plus or minus 2 square root of 2. And then add the 1 to both sides. So n equals 1 plus or minus 2 square root of 2. The quadratic formula is probably the most familiar and comfortable way to solve a quadratic equation. Remember that the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And before you ask, I am not going to sing it for you in this recording, although you are welcome to pause the recording and just belt out a good rendition of the quadratic formula to the tune of Pop Goes the Weasel. Now the discriminant is the part under the square root, the b squared minus 4ac. And it's useful in determining what types of answers to expect. If the discriminant is greater than 0, the part under the square root is a positive number. That means you'll have two distinct real solutions. Graphically, that means that you have two x-intercepts. If the number under the square root equals 0, then all you have left is negative b over 2a, which means you have one repeated real solution, or one x-intercept. And if the number under the square root is less than 0, in other words negative, you will have no real solutions. Because remember, a negative square root is not, a square root of a negative, is not a real number. That also means that the graph is not going to touch the x-axis at all. All right, let's do some examples. First of all, we're going to solve this equation by factoring. This is a fairly simple one to factor. Pause the recording, give it a try, and resume the recording to check your answer. All right, here we have the process. Make sure you factored correctly. The solution should be 4 and negative 2. Now try this one by factoring. Remember, you need to get everything on the left side of the equation and it needs to equal 0. Pause the recording, give it a try, and resume the recording to check your answer. Again, check your factoring, make sure you factored correctly. You should get negative 3 halves for x and 11. I'm going to solve this one by extracting square roots. Now it says when a solution is irrational, list both the exact solution and its approximation rounded to 2 decimals. So in other words, simplify the square root. Pause the recording to try this and resume the recording to check your answer. Taking the square root first, we get plus or minus the square root of 16, which means we need to find out where x minus 12 equals 4, but also where x minus 12 equals negative 4. Our solutions are 16 and 8. Try this one by completing the square. Notice we've already given you a head start by moving the negative 3 over to the right-hand side. Pause the recording, give this a try, and resume the recording to check your answer. First, we divide out the 9. The next thing we're going to do is take the b, which is negative 2, divide it by 2, then square it. That gives us a 1. We add 1 to both sides. Factor the left. Remember, when you're completing the square, this will always factor into a perfect square. Take the square root of both sides and add the 1. Example, you're to use your graphing utility to graph the equation and then solve it algebraically and compare your answers. Pause the recording, give this problem a try, and resume the recording to check your solution. Okay, first the graph. It looks like the x-intercepts are at 1, 0, and 3, 0, and then we solved it. The easiest way to solve this is to extract the square root. So I moved the 1 over, multiplied both sides by negative 1 to get the negative out from in front of the parentheses, took the square root of both sides, and then solved for x minus 2 equals 1 and x minus 2 equals negative 1. Doing this, we confirm that our solutions are indeed 3 and 1. Now you're not going to solve this one, but instead you're going to use the discriminant to determine the number of real solutions. Remember, the discriminant is just the number under the square root in the quadratic formula. So you're going to find b squared minus 4ac and interpret what that solution means as far as the number and types of solutions. Pause the recording, give this a try, resume the recording to check your solution. Okay, putting in the numbers for the discriminant, we get negative 15. Since the number is less than 0, there are no real solutions to this equation. Now use the quadratic formula to solve this equation. Pause the recording to try it, resume the recording to check your answer. And here you have it, from beginning to end, putting all the numbers in. We get negative 2 plus or minus the square root of 11 over 6. Now we're going to do a couple of application problems. We have a position formula, s equals negative 16t squared plus v sub 0 t plus s sub 0. The negative 16t squared represents acceleration due to gravity. The v sub 0 indicates the initial velocity of the object, and the s sub 0 indicates the initial position. T stands for time. An aircraft flying at 550 feet over level terrain drops a supply package. How long will it take until the supply package strikes the ground? And the aircraft is flying at 138 miles per hour. How far will it travel horizontally during its descent? Pause the recording, give this problem a try, and resume the recording to check your answer. To solve this problem, when an object is dropped, its initial velocity is 0. So we're going to put in the number 0 for v sub 0, for initial velocity. That's going to let us solve this by extracting the square root. So we're going to subtract the 550 from both sides, divide by negative 16, and then take the square root. Now notice two things. First of all, we are not giving this answer as a simplified square root. The reason for that is that this is a real-world problem, and the answer makes much more sense as a decimal. Notice we are also not giving the positive and negative answer when we take the square root, because again, for this particular problem, the number actually has a meaning. It's time, and you don't have negative time. So our time for the drop is 5.86 seconds. Now, what we're going to do is we are going to convert the seconds into hours and then multiply by the speed of 138 miles per hour to get the answer to the second part. We convert the seconds to hours by dividing 5.86 by 3,600, and then we multiply that by 138 for a final solution of 2.2 miles. Here's another example. Sorry about the quality of the picture here, but hopefully it'll give you a little bit of an idea. A winch is used to tow a boat into a dock. The rope is attached to the boat at a point 15 feet below the level of the winch. Use the Pythagorean theorem to write an equation giving the relationship between L, which is the diagonal length, and X, which is the distance between the boat and the dock. Find the distance from the boat to the dock when there is 75 feet of rope out. Pause this recording, give this a try, and resume the recording to check your answer. All right, using the Pythagorean theorem, we have that x squared, which is a variable distance, plus 15 squared, which is fixed, that distance will never change, equals L squared, which again is variable depending on the amount of rope. And simplifying that a little bit, we get x squared plus 225 equals L squared. Now the second part of the question, after it asked us to use the Pythagorean theorem to show a relationship, the second part wanted to know how far from the dock the boat is when there's 75 feet of rope out. So we're going to put 75 in place of L, and we're going to simplify, and we find that there are 73.48 feet of rope. There's 73.48 feet from the boat to the dock. Now again, notice we left our answer as a decimal because it makes more sense in a real-world problem. We also did not give a negative answer because that would make no sense considering the nature of the problem.